Hello, everybody, and thank you for joining us for Decoupling Metadata Leveraging Queryable Iceberg Tables for Scalable Cross-Engine Innovation. My name is Kelsey, and I'll be your moderator for the session today. Just a heads up, we will have time for a brief Q&A after the presentation, so be sure to ask the presenter tab and ask your questions and engage with your fellow attendees. With that, I'd love to welcome our speaker, Karthic, with E6 Data to the stage.
Hey, hello everyone. Really excited to be speaking at the event. Firstly, thank you for everyone all around the globe for joining in. And I'm Karthik, I'm principal engineer at E6 Data, where we're pushing the boundaries of building a new generation query engine for lakehouse tables. And this talk is about decoupling metadata and how can you, when you decouple the metadata from your iceberg tables or any lakehouse tables in general, that leads to a massive innovation, that leads to like a lot of advantages across the spectrum. And we're going to focus why this is a fantastic idea and how it has worked really well for us at T6 while we're building a high performance query engine for iceberg tables. So to begin with, let's see what is this talk about, in a nutshell. So this talk is about standardizing an interface to query and access the metadata across the system, right? And how this leads to innovation across different query engines. If the metadata layer is unified and the interface to access the metadata is standardized, right? And also we'll be proposing that it would be fantastic to have this standard being adopted across the community, in case if we can arrive at a consensus on under that everybody agree upon. And what this talk is not about, I think though we will talk about some of the ways how we went about implementing an interface at E6 Data to serve metadata, to query the metadata, but the focus of this talk is not about the implementation details of building this interface or what is the backend implementation for building a queryable interface for the metadata. So it would be more about the advantages of the architecture in case if we move to a world where the serving the metadata becomes accessible through a standard interface, right? So we wouldn't be dwelling too much into specifics of internals of how a query engine works and how the implementation is done, but rather focus on the idea of serving the data or having access to the metadata of iceberg table through a standard queryable interface. So firstly, for those who might be new to the iceberg world, what is stable metadata and why would query engines really need it? Query engines like E6 Data, like Spark, like Trino, like Dremio, it could be any query engine. Why would they really need this metadata? Right. So iceberg's metadata it's actually present inside the iceberg table itself. The specification gives you the structure of the metadata and how they are linked with each other and the relationship between them, right? The specs very clearly details the metadata file through a chain of manifest list to a chain of manifest file, and potentially it's literally like an index, typically what you would have in your file system or in your fat file system, but instead you have this blueprint of metadata of your file inside your iceberg tables, right? And the spec very clearly dictates what this metadata is and what details it should contain, and the hierarchy of the metadata really well. Now, why is this metadata important for a query engine, right? How does, in what ways a query engine leverages or takes advantage of this metadata, right? So it's really important for query engines to perform really well, to be able to do a lot of operations like query planning, optimizing your plans, or you need to also prune your data, you need to do file skipping, you might have to perform cost optimization, even to build a lot of subsidiary tools, let's say guardrail for your SQL queries. So for a query engine or to design a query engine, the metadata of your Iceberg tables is a critical component, like which goes into like the functioning of the important components that constitutes a query engine for your lakehouse tables, right? And the question is, if the metadata is already available inside your Iceberg tables, through the chain and hierarchy of manifest lists and manifest files, why do you have to index it separately? Why do you have to index this metadata externally, right? So one primary reason why you would want to index a consistent copy of this metadata outside the Iceberg table is to kind of access it, like to be able to pre-aggregate and access it, in a much more faster way, right? It's during runtime, it's not very fast to be able to interpret your metadata on the fly from the object storage. So it's much easier, much faster, and it's more accessible if this metadata is indexed outside of your object storage, and you maintain the consistency of the data. And another important reason is that once you the metadata that is provided by the Iceberg spec or offered by the Iceberg spec is definitely like great for the engine, is necessary for the engine's functionality, but a query engine needs much more than the simple metadata statistics that's available inside your Iceberg tables, right? The query engine needs like aggregated statistics. It could be like the NDVs, it could be for histograms, right? These are kind of the materialized computation of your Iceberg metadata statistics. So you need much more than like what's readily available inside your Iceberg tables, and that is or the data that is being dictated or by the Iceberg spec. And also having this data easily accessible make it so much easier for other components to consume this data. It makes it much more simpler for other components to interpret or make sense of this data, without having to necessarily understand Iceberg format, and having to use an Iceberg client and interpret in many ways, right? And also it leads to much more decoupling and faster innovation if this data is readily available, or indexed like outside the Iceberg tables. And it's a general practice today all of the query engines follow. You might see it could be Spark, or it could be Snowflake, or it could be E6 Data, Trino. All of this engine is one or the other way, they compute the statistics, they create a materialized version form of the statistics internally to be consumed by the compute engine. And now the question is, if all the engines are already indexing this data, are already storing this data in a materialized manner, what is the issue, right? Like anyway, all the engines are already doing it, right? But the problem is that there is no standard interface that exists today to query this metadata statistics, right? So now what does it mean? What is the disadvantage of not having a standard interface to consume this data? So while all the engines store this metadata in one or the other form, and there is a significant downside for not having standardization to consume this metadata. And as a result, it's really hard to build like a consistent optimizations across diverse engines, right? Like for instance, if let's say that you Spark, or or a Trino, or maybe a third party project is really excels at building the metadata, there is no way to kind of other engines to kind of consume this metadata, because there's no standardization, right? It's very hard to plug into the metadata that is being built by different engines. So literally it's like a closed source of data. It's sometimes indexed in memory, sometimes indexed in a third party data stores. So there is no way for you to plug in a consistent manner across engine to leverage this metadata. And another reason is as a result, it doesn't foster a level playing field for advanced optimizations, which means that every engine that's being built today is kind of trying to reinvent the wheel. And as a result, this significantly like slows down the innovation that could have potentially happened on the query engine world, like on Iceberg tables, right? The reason is like you have such a tight coupling now, not just with the metadata, but also all the other components which now consume this metadata, right? And these are very tightly coupled. You cannot decouple these components because each one of these components, like planner, it could be your compactors, it could be your query guardrails, all of these components, or it could be your executor pruners, right? Where you want to perform data pruning or data filtering style queries. Now, all of these are so tightly coupled, to your metadata layer that you cannot disaggregate them and plug that into maybe a better system which has much more richer statistics, right? It's tightly coupled, and that kind of leads to like a very monolithic world in the query engine, to be frank. And redundant development effort, right? Every query engine, as I said, it's like if a next generation query engine is built, or maybe the n+1 query engine that's built in the market, now also have to now reinvent this wheel, right? If the standard interface would have been available, they could have just banked on this rather than reinventing the wheel of having to also build this component. Now, of course, with tight coupling, comes high integration friction and also the massive complexity, right? And as a result, right, the innovation slows down significantly. What does that mean? Assume that like I'm a scientist working on building next generation planner for query engines. Now, the fact that it is, since there is no standard way to consume all the rich metadata statistics that I need, it's super hard for, as a planner scientist, for me to just focus on my innovation on the planner, because I'm so tightly coupled and dependent on the metadata being readily available, that I cannot escape this nightmare of having to build the metadata first, and have a way to consume this metadata, and then go on to focus on my innovation on planner, right? And as a result, it's very hard for you to switch the components of a query engine. So this like literally bundles all the components or glues together all the components in a manner that you cannot decompose them and assemble your own query engine, right? As a result, right, you see less vendor competition in the query engine space, because it makes it exponentially much more harder to to have startups which can solely focus on one aspect of the query engine and build their company. So you literally have to assemble the entire unit, and as a result, you don't see like a plethora of options today in the market to say like on planners, or could be on compactors, or could be on query guardrails. You don't see like tons of open source project which is dedicatedly building some of these components, right? You either see a query engine as a whole, or maybe a component which can be plugged out, right? So hence the whole acceleration that could have been possible in the query engine space, it's not possible today because of lack of standardization. And there is also a scalability aspect to this. This now goes to the implementation details of how you store and how you serve the metadata. Now, as tables grow large and large, I think in the keynote yesterday, one of the most important, or maybe like a significantly important topic that was discussed was a disruption to the metadata structure, which is something that looks like there's a high potential to change the way metadata is stored in the V4 version. I think today we at E6 Data, while working with a bunch of customers with few tens of petabytes of data, sometimes even hundreds of petabytes of data in Iceberg tables, we've seen that the metadata itself bloats to the point where you have over 200, 300, and sometimes even we have seen up to 400 GB of metadata, which becomes really hard to store and perform different kinds of lookups on this data. It could be for pruning purposes, it could be for planning purposes, or any other components which might want to consume this. Right. And another big drawback of not having a standard interface to serve this metadata is today, as we see that most of the streaming vendors, it could be Confluent Kafka, or it could be Stream Native, it could be startups like Rising Wave. Red Panda. Now all of them are embracing like streaming your data as Iceberg tables, right? But these systems are still far away from being query engine friendly. The reason is that even after a new snapshots are created, a query engine still needs to go and construct the metadata, to ensure that the data is queryable. So the creation of snapshot alone does not guarantee you the readiness of queryability of the data, right? So if there would have been a standard interface, it opens up a huge opportunity for all the streaming vendors to compute all the metadata statistics, the statistics a query engine that it might require, for the data to be queryable while streaming the data into your Iceberg table, right? And that can drastically cut down on, on very strict SLAs or ambitious SLAs on how fast your data can be queryable on Iceberg tables. Compared to the world wherein today, like you have to wait for the snapshot to be created, and then you run an asynchronous task in the background, which then calculates all the metadata and for the data to become queryable in a later point in time, right? And today, you don't hear any of the streaming vendors talking about computing this metadata on the fly, because that opportunity doesn't exist because of the lack of standard interface. Now, let's move to like how a potential solution to this problem would look like, right? So it's pretty simple, right? I wouldn't want to propose technical details of like how it might look like, but the idea on its own is something that I'm trying to evangelize by this talk. That firstly, like we need to come up with a standard interface, through which you can access the metadata, or potentially even could query the metadata in ways that you would want, and thus leading to like significant decoupling of the multiple components or Lego pieces that goes into building a query engine. And this could significantly lead to a lot of innovation across engines, right? As you could see in the diagram, that if there is a standardized API interface, like for accessing the metadata, and I think multiple query engines now can use this layer instead of like baking their own metadata layer in variety of different ways. Okay, and one interesting idea of how a very high level idea of how one could go about storing this data, and a bit more of an high level implementation detail would be like to store the data, as I said, either in Postgres or either in Iceberg table, in a way that not just you're able to access the data, but you're also can perform filtering style queries, or even sometimes if you would want aggregation style queries. And I think that would be much more powerful than just storing the data and just accessing it randomly. I think the ability to be able to query the metadata itself, I think, opens up a huge opportunity for multiple components. So this could be this is one of the ways we tried leveraging the metadata, and also we found it to be extremely beneficial to be able to not just store, but also store it in a manner it is backed by a database or an engine where you can even query this data, right? And the idea here is that you have a standard metadata collection layer, and here are some of the components of a query engine which now can consume and leverage this data independently without having to be tightly coupled into the different components of your Iceberg tables, right? And one such really useful component would be your query guardrails, right? You would want to build a query guardrail in order to kind of I would say a short circuit what could otherwise be a very expensive SQL query on your warehouse. Now you can like look at the metadata statistics, you can analyze it, and potentially avoid like you can like short circuit or trip what otherwise could have been an extremely expensive or a computationally expensive query on your engine, right? This is one of the use case, like potentially that can open up the innovation if these systems, or a system like Query Guardrail, which now can access this data in a standardized manner. And another use case is to build a cost-based optimizer. Like a lot of the optimizers need access to this rich metadata, And if this metadata is accessible in a standardized manner, now a lot of innovation in open source and across industry can potentially happen on just on the optimizers, right? Which can now consume this data and come up with interesting ways of optimizing. And of course, as I just mentioned, it opens up an opportunity for all the streaming vendors in the ecosystem to be able to compute all the metadata statistics on the fly. And thus, actually, if you see, this could be the opening for all the streaming ingestion system or real-time ingesting system to become much more query engine friendly. If you see today, there is a massive disconnect, right? Streaming vendors just care about streaming data into Iceberg table, but they're not heavily skewed towards being a friend of the query engine or like helping a query engine to perform its job better. And as I said, like another great advantage is that imagine if your metadata, layer is now accessible through a standard interface, you can literally take a planner from one query engine, and you can take like a SQL guardrail from another engine. Maybe you can even plug in an executor from some other engine. You can literally go about like, assembling your query engine like Lego pieces, right? How all of us, I think, while growing up might have assembled our computers, like literally you can pick your stack. You can like look at, hey, the planner, there is open source planner, which is really great, right? If it's better than Spark, Trino, or anything that's out there, you can go and pick that. And if you think the executors of some another startup is really good, you can pick that. And it also opens up a huge opportunity for startups to say, like, doesn't need to really build the entire query engine. They can just focus on innovating on just one layer and be good at it, and use that as a strategy to enter the market and then expand further. But it doesn't happen as of today, right? Assembling an entire query engine, it's like I think it's such an ambitious project on its own. You see very, very few companies venturing into building one, because like there is no point as of today to innovate on one of the layers and enter the market. And here is a very interesting use case on how we leveraged it while building the next generation query engine for Iceberg tables at A6 Data, right? And so the challenge we had was we had about like 200 GB of metadata of Delta Lake tables, right? And so we had like about a massive Delta Lake table, and the metadata itself, of the checkpoint data and other associated parquet metadata stats all amounted to close to 200 GB, right? Our initial approach was that to see, hey, let's store this data in PostgreSQL as a denormalized statistics table, and leverage that, for our pruning queries and for compaction queries. I mean, if you're wondering like why would a compactor need this data? So typically, one of the interesting things that we tried at A6 Data was that you don't have to compact your entire Iceberg table, but rather focus on what are the most used tables and partitions in the hot path of your queries, and just apply the 80-20 rule or 20-80 rule, right? Like, so 20% compaction can lead to 80% of optimization, because most of the queries just are targeted towards like, those partitions and those tables. So once we identify that, we leverage the metadata to query and ask a question that, hey, give me all the smallest files, by size on this partition, on this table, and aggregate these until the size of the aggregated parquet files amounts to greater than 128 MB and less than 512 MB, right? By just performing this simple query on the metadata, we were able to get the candidates of the small files that we need to compact in batches. Then we perform different batches, and then we lock the table and perform the compaction fast, and create a new snapshot of the compaction. So this is one very interesting use case, like how we were able to leverage when the metadata which is stored in a queryable manner, right? It's just, so again, emphasizing the fact it's not just about storing the metadata, but storing it in a way that's queryable, right? But since the metadata size was continuously growing, we started, I mean, initially it was about 200 GB, but it was growing fast. We realized, like, we are about to hit a bottleneck by storing this data in Postgres. And then, we saw that, it's not a very scalable approach. We might have to, again, come up with a new strategy in the future if the volumes grows, like, significantly bigger than what we started with. and hence we pivoted to store the metadata of iceberg tables as another iceberg table, right? So, and then it gives you now opportunity to plug any query engine of your choice. You could even like take something as small as Duck or Spark. I mean, we even tried our own engine on the metadata and were able to like leverage this. So, and it also opens up a very interesting paradigm that we see today in the computing world. I think the last era was about separation of compute and storage, and that's when like you saw this movement of data lakehouse emerged, right? Because the industry realized that it's much more cheaper and performant to have your data stored in object storage like S3 or MinIO, and then let compute engines be a pluggable component, where you just plug and query. And but a new paradigm that's now emerging is to like separation of compute from compute, which we very dearly embrace inside E6 data. And the idea here is that you know um, um, take every fine-grained responsibility of a query engine and build and separate that out as a functionality or component of its own, very similar to like what happened with the microservices revolution, but like taking that concept and extending it to the computing world, right? Or a high performance computing world. Now as a result, right, when all these components are disaggregated and they pretty much operate like a granular, fine-grained, focused component, or pretty much like a microservice, I think it really fosters the overall innovation and growth in the ecosystem, and it makes interoperability between engines much better than what it is today. Unfortunately, like today we just cannot like plug out one component of a query engine, assemble into another. So there is literally very less interoperability. So the idea here is that though we were able to separate storage from compute, but the entire compute piece is so tightly coupled, you cannot separate compute from compute, which means like you cannot literally pluck out the components and plug one of the compute component from the query engine and like how a transformer assembles itself, right? You cannot assemble your query engine, which means there is no separation of compute from compute as of today because of this tight coupling, right? I think the next very interesting paradigm that we are about to see in the industry is the separation of compute from compute, which means all the compute components, it's not tightly coupled, right? And they can be broken down, and they have standard interface of communication between each other, and so that like it opens up huge potential for you to like make all the query engines interoperable. And I think the best path we feel like and towards like getting to this world wherein there is a massive interoperability because of standardization of communication between different components. I think the best place to do this is to have allocations or potentially have a place in Iceberg Catalog API to facilitate this, right? And Iceberg Catalog API, of course, it's now the gateway for your Iceberg compute engines, and it has so much power in the or such a significance in the Iceberg world. And I think that is the best place to introduce standardization. And to begin with, I think though the standardization can come across multiple components, I believe that by standardizing the metadata access layer, it opens up the opportunity to separate or disaggregate so many more components. I think that would be a great starting point, but I think we need to move much further than building the standard interface for just metadata. But still, it would be a great starting point for us to move towards a world where there is a massive standardization of communication between different compute components of a query engine. Okay, and lastly, thanks for tuning in. Really honored to speak at the event, and would love to connect with you folks. The QR code, you can use it to connect with me on LinkedIn. And also I write a lot around Iceberg, on how to perform high performance computing and writes and reads and different interesting concepts around Iceberg. So do tune into the blog at E6 Data. Would really love to get your feedback on LinkedIn and would really love to connect. Thank you for your time.
Thank you so much for taking the time to be a speaker today with us. We did not get any questions, so I just wanted to thank you. And then as a reminder, all sessions will be available on demand within an hour after the event has ended. And then up next in track 4, we have the Apache Iceberg powering open data lakehouse at scale with Manish and Bintha at Apple. So we'll see you there. Thanks so much, you guys.